Today I'll be discussing chapter 5, circles from home 2, and our main subtopic for today is circumference, length of arc, area of circle, and area of sector. Okay, I have few shapes here. I have circles here with different questions. So let's start one by one. Before we start the question, I would like to tell you all on the formula part first. Okay, first of all, you need to know how to calculate circumference. What is circumference? Circumference is outer part of your circle. Okay, so circumference is equivalent to 2 pi r or pi d. I always suggest my students to go with 2 pi r because the other formulas all will be using radius. So it's the best to stick with radius. Okay, so circumference, if I show you all here, circumference is the outer part of the circle, the whole circle. Okay, next one you need to know is area of circle. Area of circle means they want to know the area of the whole circle. So area of the whole circle will go with pi r square. Remember, area will have radius power of 2. Okay. The next formula refers to length of arc. For length of arc, it's related to formula circumference. You will see later how is it linked to. So your length of arc is theta over 360 equivalent to arc length over 2 pi r. Okay, why are we using 2 pi r? Because this is referring to the whole circle circumference. Okay, and arc means to say just a small part. Can you see? This whole thing is a circumference, whereas arc is only a small part from here. So we are going to take the angle given, and also we are still going to use the formula of circumference, which is 2 pi r. Okay, and the last formula for this chapter is area of sector. So when we are going to talk about area of sector, we are going to relate back to area of formula, where theta over 360 is equivalent to area over pi r square. So if you can see, this pi r square is coming from area of circle. Okay, sector means this, a small part of sector. So you need to know a specific angle to calculate that area of sector. Okay, so these are the 4 formulas which will be given to you in exam. How do you apply? Let's start with the first question. In the first question, they have given you radius here, which is 5 cm. Remember, diameter is the whole thing, touches both sides of circumference, whereas radius is just half of it. Okay, so for the first one, let's calculate what will be your circumference. Your circumference will be 2 pi r, which will give you 2 times 22 over 7 times with your radius, which is 5. Okay, so 2 times 22 over 7 times 5, which will give you the answer 31.43. You can also use your pi as 3.142 depending what is given in the question. For area, let's calculate the area of circle. So for area, we will use pi r square. So 22 over 7 times with 5 square. 22 divided by 7 times 5 square, which will give you 78.57. Direct to the point. Okay, this is for circumference and also for area. Let's see the next question. In the next question, you can see sector here. Okay, if you can see, there's a highlighted part where they want you to find the arc. Okay, so they want to know the length of arc. So let's write down our formula first. Theta over 360 equivalent to arc over 2 pi r. So the first thing is write down your formulas. Next thing, what's the angle given? The angle given is 48. So 48 over 360 equivalent to arc, we don't know, over 2 times 22 over 7 times your radius is 3. It's 3, not 3 squared. Okay, once you already substitute into your formula, your work is to calculate the arc. Okay, to calculate your arc, what will you do? You bring this whole thing above. So the relationship is divide. So when you bring up, it will become times. So 48 over 360 times 2 times 22 over 7 times with 3. This will be the answer for your arc. 48 over 360 times 2 times 22 over 7 times 3, which will give you 2.51. Or you can leave your answer in fraction. Okay, so this is for length of arc. Okay, for this next question is the same, but if you can see, they are asking for the major arc, which is this part. Okay, for major arc, you need to use the major angle. The angle given here is for the minor arc. 72 is for the minor arc. So you need to calculate what's your major angle first. Okay, so to calculate your major angle, one circle is 360. So 360 minus 72 to know what's your balance. So here will be 288. Okay, so to calculate your major arc, we're going to use the same formula again. 288 over 360 is equivalent to arc over 2 times 22 over 7 times 1.4. So as usual, bring this whole thing up, which will give you arc equals to 288 over 360 times 2 times 22 over 7 times with 1.4. 288 which will give you the answer 7.04. So always remember, minor arc, minor angle, major arc, major angle. A circle carries 360 degrees. Okay, so let's go to the next one. Next one will be covering area. Okay, we have three different questions. The first one, they're asking you to calculate the area of this sector. So can you see this is just a part of the circle, so it's called a sector. So your formula for area of sector is theta over 360 theta over 360 times area over pi r squared, its radius power 2. So let's substitute 105 over 360 is equivalent to area over 22 over 7 times with 5 squared. So as usual, this whole thing you can bring up. So your area of sector will be 105 over 360 times 22 over 7 times with 5 squared. So you will get your answer. Which will be 22.92. Please round up to 2 decimal places unless they require 3 decimal places or 1 decimal place. Okay, so now the next one, it's a bit of problem solving where they have given you the area, they have given you the angle, they want you to calculate the radius. Okay, so where is your radius? Your radius is here. So as usual, first step, substitute everything into your formula. 124 over 360 equivalent to 80.1 over 2 times 22 over 7 times r. Okay, so right now your unknown here is r. You're going to calculate the value of r. So how are you going to shift one by one? Okay, I'll suggest you all to cross multiply them first. So 124 times 2 times 22 over 7 equivalent to 80.1 times 360. This could be your first step. Okay, your next step, since you only want to calculate the value of R, the relationship of the rest here is times. So if you're going to bring them on the right side, it will become dy. So how can you do this? The best is to shift all together one time. So your R equals to 80.1 times 360 over 124 times 2. Sorry. Formula for area don't have 2. It's 2 pi r. So sorry, it's pi r square. So here will be r power 2. R power 2. Sorry, I wrongly used the circumference formula. So there won't be 2 here. Wait a second. Times 22 over 7 times r square is equivalent to okay. So to calculate the value of r, the rest of it will be shifted on the right side. Times will become dy. So times 22 over 7. So r square will be remaining here. Okay. So press your calculators. 80.1 times 360 divided by 124 times 22 over 7, which will give you the answer 73.99. And this is power 2. To find power r, we will square root 73.99, which will give us the answer 8.6. So your radius is 8.6. Okay, so remember earlier I wrongly substituted 2 pi r. For area, you will use pi r square. Okay, the last question, the trick part here is they have given you the area. They have given you the radius. They want you to calculate the angle. Okay, so let's copy down your formula first. Theta over 360 equivalent to area over pi r squared. So substitute what you have. Theta you don't know, 360 over area is 48.4 over 22 over 7 times with 13.4 square. Okay, so now to calculate your theta, this one is quite easy, direct. We are just going to shift the 360 to this side because relationship is dy. Shift up will become times. So theta equivalent to 48.4 over 22 over 7 times 13.4 square times 360. That's all. You can directly press your calculator. Divide by 22 over 7 times 13.4 square, which will give you the answer 30.88 degrees. So this is your angle. Next, important things you need to know: if they're giving you one whole circle, your angle is 360. If they're giving you half circle, semicircle, your angle will be 180. If they're giving you a quadrant is 1 over 4 of the circle, which will carry the angle 90 degrees. So be careful when you're answering this chapter's question, whether they are looking for minor arc, major arc, minor sector, major sector. The radius will remain the same, but the angle will change based on the shape, based on the sector that's given. Okay, that's all. Thank you for watching.